Hello students, myself Dr. Divya, Assistant Professor at Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will discuss the problems on gross calorific value or the higher calorific value and the lower calorific value or the net calorific value of any fuel. So before going to the problems, we should even understand what is the calorific value of any fuel. So the calorific value or the heating value of a solid or liquid fuel. So calorific value is nothing but the heating value of any fuel, whether it is solid or liquid. So that is defined as amount of heat given out by complete combustion of 1 kg of fuel at normal temperature pressure conditions. So this fuel has the capability of combustion. Only upon combustion we get energy in the form of heat or energy that can be used for any of the automobiles. So it is the amount of heat given out complete combustion. So whenever there is complete combustion, so it includes everything. So complete combustion has to take place to give heat. So whenever it is giving the heat, complete combustion, due to complete combustion per kg of a solvent, kg of fuel, it is nothing but the calorific value. So it is generally expressed in kilocalories per kg of fuel at normal temperature and pressure. NTP is normal temperature and pressure conditions. So SI units are joule per kg or kilojoule per kg or megajoule per kg. So how did we get these units? So for example, we are saying that amount of heat is coming out per kg of fuel. So what is the units for heat? Kilojoules. So kilojoules per kg. So that is how kilojoules per kg is given for the units as for the calorific value of any fuel. So there are different types of calorific value, higher calorific value and lower calorific value. So why is it higher and lower again? Because complete combustion includes everything like moisture and all. So whenever the calorific value is just because of including the latent heat of steam also, then it is called as higher calorific value. Therefore, it will be very, very high compared to the net calorific value and the actual calorific value that we are obtaining for during our usage. So higher calorific value of fuel or the gross calorific value. So gross calorific value or the higher calorific value are the different terms that we use, and it is the total heat liberated by complete burning of 1 kg or 1 cubic meter. So if this is in the liquid state, if at all the fuel is in liquid state, we use it 1 cubic meter. If it is a solid fuel, we use it 1 kg. So it is the total heat liberated by complete burning of 1 kg or 1 cubic meter of fuel, including the heat of steam. So how we are getting the steam? Just because of moisture that is present in the fuel. So if at all there is moisture, that even gives out the steam. So heat of steam is also contributing to this calorific value. Therefore, it is the higher calorific value or the gross calorific value. So how did we get this? The heat of steam formed by combustion of hydrogen in the fuel. So this is given by a formula by scientist Dulong. So he proposed this formula after several experiments and gave this like 33,800 of carbon, C is carbon. So these are the main constituents of any of the fuels. So therefore, carbon, hydrogen, oxygen and sulfur. These contribute to the energy that is produced from the fuel. So therefore, these are included in the formula and given the higher calorific value formula. So 33,800 C plus 144,000 taken in like hydrogen minus oxygen by 8 plus 9270 sulfur, and this is the units that we use for the expression of calorific value. So similarly, there is also lower calorific value or the net calorific value used. So whenever we are using gross, we use net. Whenever you are using higher, we use lower. So lower and net is equal, gross and higher is equal. Okay. So what is this lower? It is the total heat liberated by complete combustion or complete burning of 1 kg or 1 cubic meter of fuel, deducting the heat of steam, because this doesn't contribute to any usage in our machinery or automobiles. So therefore, we do not use it for that. So therefore, deducting the heat of steam, there is some calorific value, useful calorific value for our application. So that is nothing but the lower calorific value, and that is formed by combustion of hydrogen in the fuel. So this heat of steam is just because of combustion of hydrogen in the fuel. So therefore, the total heat liberated by complete combustion of kg or 1 cubic meter of fuel deducting the heat of steam is nothing but lower calorific value or net calorific value. So this is again given by formula. So why we are the scientist has proposed the lower calorific value is equal to higher calorific value minus 9H2, that is hydrogen, into 2466. So this is kilojoules per kg. So why do we have to really take in the consideration the higher calorific value? Because that includes the heat of steam. Heat because of steam. So whenever we want to deduct the heat of steam, that we can do it from the higher calorific value. Any fuel upon burning will give the actual calorific value or the higher calorific value. So when we want to know the actual calorific value, we have to deduct the heat of steam. That can be done by subtracting from the higher calorific value. So there is a contribution from hydrogen also. So therefore, we are including this in the form. So these are the different important formulae that we are using in the fuels chapter or the module. So theoretical CV or the calorific value of the fuel is equal to 33800 carbon plus 144,000 hydrogen minus oxygen by 8. This is the atomic weight of atomic number of oxygen plus 9270 sulfur. So this is what we use it for the higher calorific value, that is the theoretical calorific value formula. Then lower calorific value is higher calorific value minus 9H2 into 2466 and expressed in kilojoules per kg, that is a unit as a unit for the calorific value. Next one is the formula for the mass, a mass of air required for complete combustion of 1 kg of fuel. So air is required for combustion. So therefore, how much air is required is also need to be calculated. So this is a formula, we take it in consideration, and it is only the mass. Therefore, only kg is given for the units. And mass of excess air supplied, it is nothing but 100 by 23 into mass of excess oxygen that is present. So that is how we get the different masses of excess air and a mass of air that is required for combustion. So now let us see the problems that involves the calculation of higher and lower calorific value or the HCV and LCV. So a sample of coal having the composition on mass basis. So how much is it? Like carbon is 70%, hydrogen is 7%, sulfur is 1%, oxygen is 10%, and ash is 5%. Calculate using Dulong's formula higher and lower calorific value, that is HCV and LCV of this fuel. So coal fuel has all this composition after testing. So now we have to convert into mass basis, like carbon is 0.7, hydrogen is 0.07, and sulfur is 0.01 because it is 1%, and oxygen is 0.1%. And now we know that Dulong's formula is 33,800, Cr 1 like 44,000, taken in like hydrogen minus oxygen by 8 plus 9270 sulfur, and expressed in kilojoule per kg. So putting in the values, 33,800 into 0.7, that is the carbon. Carbon is 0.7, 33,800 into 0.7 plus 144,000. What is the hydrogen value? 0.07 minus oxygen 0.1 by 8. Okay. Plus what is the sulfur value? 0.01. into 9276. Why are we not taking into consideration the ash? Because no contribution to heat. No contribution to heat liberation. So therefore, it doesn't involve in the calorific value calculations. So after simplification, we get the value 32,032.7 kilojoules per kg. So this is the higher calorific value or the HCV value of that coal sample. The lower calorific value HCV minus HCV minus 9H2 into 2466. So 32032.7 minus 9 into what is the hydrogen value? 0.07 into 2466. So upon simplification, we get the value 30479.12 kilojoule per kg. Whenever you see, there is always the lower calorific value is always low compared to the higher calorific value, because we are subtracting the higher calorific value and calculating the lower calorific value. So therefore, this is the higher and lower calorific value or the HCV and LCV of this particular coal sample. Next, calculate the HCV and LCV of a coal specimen from the following data per kg of coal. So per kg, they have given in percentages, like carbon is 70%, hydrogen is 6%, oxygen is 8%, sulfur is 5%, remaining is ash. So whatever is remaining, it is ash and no contribution to the heat or the energy that is liberated. So therefore, we do not consider. So to calculate the HCV and LCV, we need to use the Dulong's formula, which is given by HCV is equal to 33,000 into carbon, like in the percentages, 1,44,200 in percentages with hydrogen, and 9300 into sulfur percent plus 2250 into oxygen percent minus 6100 kilojoules per kg. So whenever we are taking in percentages, we use this formula. So now substitute the values of carbon, hydrogen, sulfur and oxygen in these values and now calculate the HCV value. So putting in this and after simplification, we get 31,323 kilojoules per kg. So kilojoules per kg as a unit is used for the expressions. Next, LCV. So use HCV is 31,323 minus 584 into 6% by 8. So this is 6 is like for the hydrogen we have 6%. So hydrogen by 8 is equal to 29,992 kilojoules per kg. So these are the HCV and LCV values. HCV is 31,323 kilojoule per kg and LCV is 29,992 kilojoule per kg. So always remember that LCV value is lower than HCV value. Next, calculate the LCV of a fuel which has 88.9% hydrogen. So 8.9% hydrogen and HCV is given here. So they have already given HCV here, calorie per gram. So we have to express in calorie per gram. So given that latent heat of steam is 580 calorie per gram. Latent heat of steam is 580 calorie per gram. So we need not calculate the HCV in this case because they have already given. So now we will be calculating the LCV or the lower calorific value. HCV is 6,500 calorie per gram and latent heat of steam is 580 calorie per gram, and the weight percent of hydrogen is 8.9%. And now the lower calorific value using the Dulong's formula, like HCV minus weight of hydrogen by 100 into 9 into latent heat of steam. So after substitution, we get 6035.42 calorie per gram. So whenever we are expressing here in calorie per whenever in the question if they are giving in calorie per gram, we even have to express in calorie per gram. So therefore use the percentage as such without converting into mass basis. So that is how we get the higher and lower calorific value. If you see here, 6500 is the higher calorific value and lower calorific value is 6035.42 calorie per gram. So always it is less than higher calorific value or the HCV value. Next, a sample of coal has the following composition and mass basis. So carbon is 60%, hydrogen is 10%, sulfur is, carbon is 60%, hydrogen is 10%, sulfur is 3.5%, oxygen is 15%. So calculate the HCV and LCV values. HCV and LCV values of fuel per kg. So given composition on mass basis, now convert into 0.6 because it is 60% and hydrogen it is 0.1, sulfur is 0.05, oxygen is 0.15. So the Dulong's formula, we are using Dulong's formula 33,800 into carbon plus 1,44,000 into hydrogen minus oxygen by 8 plus 9270 sulfur and expressed in kilojoules per kg for the units. So substitute like 3380 into 0.6 because it is carbon and hydrogen is 0.1 and oxygen is 0.05 by 8 plus 9270 into sulfur is 0.03. So that we get 20,280 plus 11,700 plus 324.45 and after adding we get 32,304.45 kilojoule per kg. So that is the HCV value that we obtained for this particular coal sample. Then LCV is HCV minus 9 into hydrogen into 2466 kilojoule per kg. So these are the units expressed. So 32304.45, that is the HCV value minus 9 into 0.1 for the hydrogen into 2466 and after subtraction we get 30085. So 30,000 HCV is 32,304.45 and LCV is 30,085.05. So this is how we get HCV and LCV values, kilojoule per kg, kilojoule per kg. So these are the HCV and LCV values for this particular coal samples. So if you see here, the values like hydrogen has 10% and oxygen is also having 10%. So the latent heat could be higher because of moisture that is present. So these are the different problems that we discuss in the HCV and LCV. So from these values, we can decide the different fuels for our applications. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.